So today we are showing how science can be stemmed from poetry. Okay. So I love connecting things to other topics because it kind of helps make it more real to your children. Okay. So if your kids are with you watching this, we will be doing two science experiments live and actually learning some scientific terms and stuff. But first off, I'm going to read a couple poems and I'm going to let you guys guess what you think the science experiment is going to be related to. Okay. So first, I'm going to read a poem out of Poetry in Spring. Okay. Let's see here. Okay, here we go. The Promise of Spring by Sophie Hart. And this is actually one of our poetry contest winners. So I'm super excited to use this one. The flower buried deep beneath the ever building snow dreams of a day not far away where spring will steal the show. The sun will soon break through the clouds. The birds begin to sing. The snow will start to creep away. New blossoms it will bring. The sky will turn from gray to blue. The streams will start to speak. New nests appear in boughs above. Small heads begin to peek. The flower breaks from bud to bloom. A promise can attest that spring will show its face again after a wintry rest. Okay, wonderful. Okay, so there's one hint. You can go turn on that light. Okay, let's see here. Let's see here. Here's one called, oh, this is from another poetry contest winner or author pick. So this is called A Season of Senses by May Salazar. Season of senses, peeping, pecking chicks, rosebuds and rainbows, itching, watering eyes, nature in bloom, gardens and green grass. Okay, there's another one. Okay, and now I'm going to read one out of A Year of Poetry Tea Time. Okay, has a section. Let's see here. It has a whole bunch of poems based on this topic. Let's see here. Which one do we want to read? I'm going to go to page 89. Okay, this is called Daffodilly by A. A. Milne. She wore her yellow sunbonnet, she wore her greenest gown, she turned to the south wind and curtsied up and down. She turned in the sunlight and shook her yellow head and whispered to her neighbor, "Winter is dead." That one's a tricky one because it's actually talking about the subject that we're going to be talking about, but it's talking as if it is a person. Okay. Oh, here's another one. Just a page or two on page 92. A seed I sow. A seed I sow, I give it a shower. A seed I sow, or a seed I grow, up comes a flower. First autumn, then winter, the flower dies, but there in the center another seed lies. That one was by Caden Shepherd, another poetry contest pick or winner. Okay, one more. And then you're going to guess what the topic is. Okay, let's see here. We're going to page 205. Oh, I keep skipping it. 205. This one is called Lodged by Robert Frost. The rain to the wind said, "You push and I'll pelt." They so smote the garden bed that the flowers actually knelt and lay lodged, though not dead. I know how the flowers felt. Okay, so what do you think the topic is related to today? Do you have a guess, Beatrix?
Hmm.
What is your guess? What do you think? Just take any guess.
Something best with plans.
Yep, something to do with plants. Okay. We're going to do a science project today that has to do, or that we get to use flowers. Okay. And this isn't even a real flower, so you don't worry. You don't have to have flowers. So for today's science project, we all you need is some colored pencils and some white paper and a bowl or dish with water in it. Okay. So while you're gathering that, okay, so again, you just need a piece of normal copy paper. Okay. You need some, what's that? Colored pencils. Not necessarily that many. You don't have to have that many. Okay. And then you'll need some sort of dish to hold water in. And I chose this one because it has flowers in it. Okay. But while you're gathering that, I'm going to tell you what we're going to be learning about today, and that is absorption. Okay. So things like paper, wood, and cotton, they all have something in them called cellulose fibers. And these cellulose fibers are really good at sucking in water. Okay. So I'm sure you guys have seen this science experiment before, but I wanted to demonstrate. So today, usually people use paper towels, but I never buy paper towels. So I'm going to use toilet paper. But if you have paper towels, you can do this. Okay, so while I'm talking, I'm gonna measure off some toilet paper here to make my little bridge. Okay, so inside wood or any plant, they have these cellulose fibers, these like little sections. And if you were to be able to like look in a telescope at like a leaf or probably wood really up close, they have all these little pockets. Okay, so the cellulose fibers are really good at absorbing water. But this is why. So within the plant or whatever, just like us, they need all sorts of different nutrients. There are sugars inside there. So when these cellulose fibers soak up water through something called capillary action. Okay, so the water is actually more attracted to the cellulose fibers than itself. So it is drawn to these cellulose fibers through capillary actions, causing action, right? They're moving up. And that's what I'm going to show you with this first thing, because there's all the little compartments, the fibers, and the water wants to go through them, wants to fill them up. And this is just like how plants even bring water into themselves. Okay. So since I don't have toilet paper, I'm going to take this toilet paper and I'm going to roll it up some. Okay. And this happens pretty quick. Okay. So I've got a glass here with some green water in it.
Suspicious green water.
And another glass with some purple water in it.
Suspicious purple.
Okay. And since I'm using toilet paper, actually, it should fit down in there good. Okay. So what's going to happen is I'm going to put this down inside and we're going to be able to see the water doing its capillary action. Okay. Because the water, again, it wants to fill in the space. So I'm going to push this down here and we're going to watch as it crawls up. Okay. So it takes a little bit of time. Okay, so what's happening is as the water goes into the cellulose fibers, there's also sugars in there. That's why I was talking about like we need nutrients and stuff. So sugars, they have the opposite polarity. Okay, so the spaces in the cellulose fill with water. Okay, and the water has negative and sugars have a positive, and those are positives or positive and negatives, they attract to each other. And what happens is it kind of locks in the water into place. So as you can see now, there's like a bluish color here and the green still traveling. So while this is doing this, we're gonna move on to our next science experiment that has to do with flowers. Because yep, it's blue, it's still crawling. Okay.
It's crawling and it turned blue.
Exactly. So what you're going to do is you're going to take something around like this, okay? And you're going to draw a couple circles on your paper here. We'll have be the demonstrator. Okay? Yes. So let's tilt this down a bit. Okay, so you just grab a pencil and you're just going to draw some circles. See, as you can tell here, the water is just drawn, okay? And again, this is just like when plants are sucking water up into them. The water wants to fill all the spaces it possibly can, and it's goes into the capillaries, and it keeps going. Okay, and they've almost met. You almost have both colors. Yep, go ahead. Okay, so you're gonna draw your few circles onto your paper. Okay, can you do one more? It's so close. Okay. So B has her circles, and I am also going to draw a circle. Okay. Okay. So inside your circles, what you're gonna do, we're gonna draw flowers. Okay. We're gonna draw some flowers, but we want to make sure they have a good sized petals. Okay. So I have some yellow on this pencil. So I'm going to draw a circle in the middle, about half the size of that circle. Okay. See how that's about half the size? And then I'm going to draw petals around. Okay. And you're going to put about that much space. Oh, look it. Our colors have met each other. Yep, it's all filled up.
That's probably really soggy.
Yeah, it's eventually it possibly would drip. I don't know. But that looks pretty cool. So I'll bring it closer. See, look at that. That water is so attracted to the cellulose fibers that it had no choice but to go up, right? Remember, that's called capillary action. Okay, pretty cool looking, right? And I'm sure you guys have seen it where you have all the rainbow colors and it goes from one cup to the next cup to the next cup. So this is the same thing, but it's just with two cups.
It's kind of like if it's climbing up like a ladder or something.
Yep. And you could do this at home. All I had was I actually only had gel food coloring and I just squeezed a bunch in and stirred it to dissolve it. So you could try this at home with different colors to see what colors it ends up creating. Yeah. Okay. So I have my flower drawn in the circle. So what I'm going to do is you can just decorate your flower any way that you would like. Okay. So you could make it multicolored. You can make it one color. Whoop. Okay. So I'm going to make the center of mine orange. Okay. Doo, doo, doo. Okay. And then I'm going to make my petals yellow. Okay. Nice and simple. Ooh, you got a bright orange center.
I wasn't really looking. I just grabbed it.
And grabbed it.
If I was gonna grab a orange or a red or something, but I grabbed this 3D color. Like
It doesn't have to be like perfect.
mine aren't perfect.
This part is just to make it fun. So what we're doing is we're going to make blooming flowers. These flowers are going to bloom right before your eyes. Okay. And depending on where you live, like we are in the Pacific Northwest. So up here, it's still pretty cold out. So we have some bulbs coming up. And at church, there are some daffodils that have come up. Ours haven't quite come up yet. But I mean, they're up. The green stuff's growing, but we've only got little crocus flowers so far, little teeny itty bitty flowers. So we're still waiting for all the pretty flowers. I'm sure other places that are warmer already have flowers growing. Okay, so I did a daisy type one here. I'm gonna make another different kind of flower, just so you can see that you don't have to just do daisy shapes. Oh, I picked two of the same exact color. That's pretty boring. Let's see here. You don't know what kind of flowers they are? I'm gonna try to make something that's almost like tulipy. Okay. So I'm going to, let's see here. How do I want to do this? I'm still gonna kind of draw that circle in the center. Okay, because we want to know because we're gonna be doing some folding. So we want to be able to see where to do our folds. but I am gonna make kind of like pointy things. I mean, it might end up looking like a daisy anyways, but I want to try something different. Okay, so there you go. So I've got pointiness, and what I'm gonna do is I'm gonna make the outer edge. I'm gonna kind of color it differently, just to make a different pretty flower. Okay, so I'm gonna do the tips of my flowers this darker color. And this is what's fun about doing like connecting different subjects with other things. Because like what so far we've done some literature. We are now incorporating art. We have we're learning science while doing this. So there's all sorts of different subjects that you can learn just from leaping off from a few simple poems. Okay. There's also, let's see here, scientific method, right? Making a hypothesis.
Hypothesize.
Yes, to hypothesize. So before we continue with this science experiment, we are going to be guessing what is going to happen. Okay, we're going to make a hypothesis, an educated guess of what could possibly happen with our flowers.
Hypothesize.
Yes, hypothesize. Okay, and then I'm going to put one more color in the center, just for the fun of it.
I'm gonna do something like this.
And then I'm going to take some brown and I'm going to put some
I'm gonna do
little
something
pollinator little thingies on here. So
like something like that.
I'm back and forth now. I was thinking tulip, but now it's looking more like a lily. Okay, so there you go. So there's my second one. Okay, so now that we have our flowers made, we are going to take a pair of scissors and we're going to cut them out. So you don't want the circle. You're going to cut out just your colored in flower parts. Okay, so like this, you're going to cut the petals out like so. There we go. Okay, so you're going to cut out all the flowers that you made. Okay, so Beatrix, what is paper made out of? Do you know? I don't even know if I've ever taught you this.
I got.
You don't think so? Paper is made out of wood. Okay, so what does that mean? This paper, just like the toilet paper, what does it have inside it? That big word we just learned. What sort of fibers are inside this paper? Paper. What do you think?
Hmm.
What does that say?
Cellulose.
Cellulose. Yep, cellulose. Because remember, I said paper, cotton, and wood are some different natural things that have cellulose fibers in them. Okay, so since these have cellulose fibers in them, what does paper do? Just like the toilet paper, what is even printer paper going to do if it's placed in water?
Do the exact same thing.
Yeah, which is what?
Um. Absorb the.
Good job. Absorb. It's going to absorb the water, right? The water is going to have no choice but to perform its magic of capillary action. And it's going to fill in those dried up cells inside our paper here. Okay, because in here are the cellulose fibers, right? And then the sugars come into contact and hold the water in place. Okay. So once you have your flower cut out, what you're going to do is you're going to fold each petal inward like that and just fold it over. Okay. Just fold and fold and fold and fold. There you go. And so you're going to end up with a neat little bundle like this. Okay. So you have a bottom and the top will have the petals on it. Okay. Whoop. So I'm gonna do the same thing here. Fold, fold, fold. You can think of like capillary, like the spaces inside your paper, okay? Because this is obviously dry paper, right? Dried up wood that's been processed and turned into paper, okay? Inside, let's draw on here. So inside the paper, which we can't see, right? You got all the fibers. So we're gonna pretend like this is a fiber, but within the fiber, there's all these porous spaces, okay? All these spots. So when the water gets in contact with the paper, it has capillary action and it starts filling in these spaces. Okay. So just like if you were to take your paper towel that's soaked up water, if you squeeze it, what's going to happen?
It's gonna go out.
Yeah, the water's going to go out, right? Because it's going to squeeze it out and it's going to drip out. Okay. So all these spaces have been filled up, but then you're going to squeeze it out and it's going to squeeze the water out of the capillary sections. Okay. So what we're going to do here is what Beatrix to finish up. I'm going to go put some water inside my dish. Now I'm going to actually put warm water inside. Okay. Because warm water will soften the paper and get inside faster than cold water because warmth makes things relax. Okay.
You did it really quick. I only was able to cut out one. Hey, mommy, something, something happened. It said sign in on Zoom.
Okay. What? Oh, is something turned on? Okay, I've got our dish with warm water in it. Let's see here where to go. La 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 la. Okay. So I've got my dish. You can see the water moving in it. Okay, got my dish of warm water. And then, okay, here's another science thing to talk about. Um when atoms and stuff are cold, they move really, really fast and they get really close to each other. Kind of like you can almost think of it like when you're outside and cold, you don't stand around with your arms way out here. You're when you're cold, you try to conserve your energy, conserve your warmth. So like all the atoms get really close, but when it's warm, they spread apart and they get more, loosey goosey and comfy. So it's the same thing with anything out there. If something's warm, it's going to be relaxed and looser. So that's what we're going to use warm water. And what we're going to do is we're going to take our flowers and we're going to place them in the water to float. We want them to float with the flat side down. So here, do you want to put yours in? I'm going to place mine on. Okay, and watch what happens. Let's see here. Oh, because that warm water isn't focusing. Oh, I can't tell if you can see that because it's being all blurry. There we go. Flowers are opening. They bloomed. Oh, goodness. Oh, there you go. Maybe if I lift it up. Did you see how that happened? Oh my goodness. We forgot to do our hypothesis. Okay, so look at that. So what happened? The warm water moved very quickly. Usually I've done this with cold water. I've never seen it happen that fast. I thought I was gonna have time to talk while it sat in the water. Because as I used the warm water, its capillary action was super fast. It like filled up all the spaces in the water
You said it would be slow.
I thought it was going to be slow too. Clearly, the
Your
warm water.
hypothesis.
Yeah, my hypothesis was wrong. But it did move fast. Actually, I thought it would move faster. I just didn't think it'd move that fast. So that was pretty impressive. Okay, so B, you're doing another one?
I have another after this one.
Okay, perfect. So we'll watch that again. 'Cause that was, I'm gonna take these flowers out. I'm actually gonna set them out because technically if they dry,
You can do it
you
again.
could probably do it again. So I'm gonna
That's amazing.
amazing.
You can do it a whole bunch of times.
Yeah.
78 times maybe.
Okay, B, you almost got a flower, one more flower there. Oh, you got one with like really a big center. That's gonna like go, it's gonna like explode. Okay, so again, lots of cool words we learned. We learned cellulose fibers, right? They're the porous structure. Porous means that it can suck in liquid, okay? And then there's sugar molecules. Sugar molecules. So the sugar molecules are attracted to the cellulose or the water, sorry, the water, and it helps lock it in place so it stays. Just like again over here, right? The water is locked in place. It is soaked in and it is not leaving. Okay. So you've got that going on. Okay. We learned about how warm molecules react more slow and loosely than cold molecules. Okay. And we got capillary action, just like how plants soak water and nutrients up into the plant. It uses capillary action. It's using that ability that the water wants to go and fill in the spaces. Okay, do you want to put that one in? Okay, let's see how fast it goes this time. Here, I'm going to leave my hand down here so it stays focused. Watch the flower as it blooms. Yep. There it goes. It's so fun. There goes a blooming flower.
I think when we're done with this thingy, I think I'm gonna make like a lot.
You make a lot?
Yeah.
And just keep watching them? It's
Keep
pretty
on
cool.
doing it.
And technically the same type of thing if you have like a cotton washcloth, if you have or like your clothes get wet. And do your clothes let go of the water very easily? No, you usually have to wring them out or set them out in the sun so the water evaporates, right? It just becomes part of the air.
Since we're gonna.
That's another big word, right? Evaporate. So yeah, that's how it works. Okay? So there is poetry with science
A fun thing you
and
could
art.
A fun thing you could do is you could have somebody guess what kind of colors the flower is.
That is
And then
true.
it opens and then see if the person's right or
Yeah,
wrong.
that would be fun. You could make a whole bunch that would fill an entire bowl and watch the entire bowl
I
bloom.
don't think I'm gonna do
You
that.
gonna do that? Maybe we'll have to share a video of that later. Okay, so lots of fun things you can do inspired by poetry for science and math and history and all sorts of things. And that is why I love making the units with the T with a poet units because you then get to read poetry and explore all sorts of things from music and science and history, biology, and your children don't even realize that they're learning because it's fun, right? It is. It's enjoyable. So, thanks for attending this class, and we'll see you again.